All right, so this represents step 3 for the binomial project. I just want to briefly go over some of the binomial information. So what I have here is just a very simple uh, concept of a binomial distribution. So in this case, we have 10 trials, but from 10 trials, you actually end up with 11 events. So if we're looking at a male-female distribution from our data, which is one of the binomial variables that we actually have, whether you're male or female, the driver was male or female. And we consider 10 trials, we have 11 events. The first event being 0 males, 10 females. Second event being 1, 9, etc. as we go through. And then if we look at our conditional expectations, in other words, our conditional means, if there's more males than expected, then our costs go up. So this is one of the things that actuaries work on, is that they're trying to define what the expected costs are over a given period of time or for a given number of accidents. From that expected cost, two things come. Number one, we price how much we should charge for insurance. So if you're male, as you see here, your expected cost of an accident is more expensive, and therefore you should get charged more than females. If we know ahead of time that you're impaired or tend to be impaired, whether it's texting or anything else, then we should probably charge you more money for your insurance than if you have a lower probability of being impaired. And then here we have good student and non-good student. And in my sample that's here, the good students are actually more expensive, or sorry, the good students are less expensive than the non-good students. So if I have an identifier that says you're a good student, meaning you have a B average, then you should probably end up paying less insurance, which is fine. So this is what we're trying to look at and what actuaries actually look at. So we need to know what the cash flow is going to be expected. In other words, how much money should we end up setting aside to pay for accidents? And we need to know how much cash flow is going to be expected to be set aside so we can price everything correctly. And actuaries need to get paid too. In fact, they get paid extremely well. Starting actuary salaries and range from 90,000 to 135,000, depending what type of actuary you are and where you're actually going to be located. Here in El Paso, it may be a little bit more to the low end of the salary, but $100,000 per year in El Paso is an awful lot of money, or $100,000 per year in San Diego or in San Francisco is actually not very much. Anyway, so what we want to do is set up this binomial sheet. And we have, let me move this guy over. We have 3 binomial sheets that are going to be very similar. So what I'm going to do is set up the first one, and then your expectation is to go ahead and set up the next 2 binomial sheets. So that's binomial based on impairment and binomial based on whether you're a good student or bad student. The process is the same. The particular variables that you pick are different. And by doing it on your own, you're actually going to learn a lot more about Excel and about how to build spreadsheets and about actuarial science and statistics and binomial distributions than if you just follow me through the steps of an underlying of this particular video. So we'll go ahead and start. First thing we're going to do is just enter some arbitrary values here. It doesn't matter. I'm going to say at most 5, meaning at most there are 5 events. At least, we'll just say 4, meaning of a particular style event, there's at least 4, so 5's good, 6, 7, 8, 9, 10. At most 5 means 0, 1, 2, 3, 4, and 5 are okay. And then exactly 5 events occurred, and we're going to enter a number of trials. And I'm just going to arbitrarily pick 10 right now. And this is the, actually I'm working on the wrong tab. Let me go back here. I want the male-female tab. So I'll just hit Control C. Sorry, I'm not perfect. Do make mistakes periodically. Control V. Control C means copy. Control V is paste. And we're going to define this one as male. And I'm going to go ahead and merge the cell, and we're going to make it underlined just to make it a little bit clearer. This is one of the things about spreadsheeting. You want to make your spreadsheets as clear as possible to the people that are going to be looking at them. So you actually spend a lot of time on spreadsheets that you think you're the only one looking at, getting them formatted correctly. And this one's going to be female. And that's because you never know who's going to end up looking at them. It could be your boss. It could be somebody that's coming in after the fact. There could be a question, did this person make a mistake? And I'm highlighting this group only so that I can open it up. You can see the equations a little bit easier. So we have male, we have female, and then we have our at most, at least, exactly. And these are the three conditions for a binomial distribution. So we'll just start with male at most. The function in Excel is equals, and I'm going to type bino and click on binomial distribution. So the first question is the number of excesses. So we're looking at male, and we're going to say at most there are 5 accidents created by males. Now you may say to yourself, is that a success? Is that a failure? And that's one of the things about binomial distributions. Your definition of what a success is kind of immaterial, or on the other hand, very material. So one normally wouldn't think of a guy getting into a car accident as being a success, but in terms of the probability distribution, that's what we're actually going to be asking about. And just to shortcut things a little bit, I'm going to go ahead and hit F4 here to lock that guy in. So as I move things over, I can just make a few adjustments and not have to retype the equation. Actually, you know what? I'm not. And you need to, a little bit of practice on typing equations is always a good idea. So the next thing we need is the number of trials. That's going to be down here. And then we need our probability. So we're going to come to our descriptive statistics tab, and we're looking at male, female. There's 50% roughly of the accidents caused by males. So that becomes our probability. And a lot of times in statistics on binomial distribution, it's referred to as a proportion. And you understand, I mean, it's a binomial distribution. You're either male or you're female. So there's really no option here in terms of the designation. So it purely fits a binomial distribution. And then the next thing we want to know is whether we want it cumulative or for non-cumulative. Non-cumulative means it's exact. So in this case, we're cumulative. So I'm going to go ahead and enter 1. So there's a 61% probability that there's at most 5 accidents caused by males out of 10 possible events. I'm sorry, out of 10 possible trials. Now remember, this means 11 events, just to go back to this tab. So what we're talking about here is we're saying, well, what's the probability, I'll just highlight it, of at least, make sure I get it right, of at least 5 male accidents. So that's actually 6 events that are occurring. So if you're a 50-50 chance, it kind of makes sense that if there's 6 events out of 11, you're going to be at 60%. So as a gut check, 60.1% really makes sense. So then we're talking about at least. So at least means there's at least 4. So we have 1, 2, 3, and 4. But we also have 5, 6, 7, 8, 9, 10, So kind of almost from 0 to all. And what that means is we want 1 minus, and we're going to go ahead and pick our, actually, we're going to say this is equal to, no, I want to type it, equal to 1 minus, and then we're going to do our bino, and that's the distribution that we're interested in. And then the number of successes, so at least 4, comma, and out of 10 trials, comma, with our probability, come back to our descriptive statistics, and male, female, so we're going to pick our proportion, the average, and then we want also a cumulative cumulative function. So it's saying there's at least a 63% probability of having at least 4 males involved in the accident. So we're actually looking at 4, 5, 6, and 7. And then if we want to do exactly, this is going to be equal to our Bino. Click on our distribution. And then the number of trials is 5. And I'm sorry, the number that we're interested of successes is exactly 5. The number of trials is 10. And then the probability, we come back to our descriptive statistics, click on that. And then finally we want a 0 because we're not interested in up to, we're just interested into that particular value. So there's actually only a 24% probability that we'll have exactly 5 accidents caused by guys, given that 50% of the accidents, in other words, on average half, are actually caused by guys. All right, come down here, I'm just going to go ahead and clear that. Real quickly, and then I'm going to go ahead and stop the video. I want to try and keep the videos to roughly 10 minutes, maybe 12, just depending on what's going on. So the next two things I'm going to do is just set my series. So in this case, we want to start with there's 0 males. In other words, we're at event 1 where we have 0 males and 10 females. And then I'm going to use my fill series command. And we're going to work on columns. And our group, we're going to go from 0 to 50. So that quickly goes ahead and fills down to 50. We're going to do the same thing for females. 0. And now we're going to pick here. And we're going to fill a series. And we're going to go down to columns. And again, we're going to click on 50. All right, so I got my 2 columns filled. I'm looking for the amount of time I've had. 12 minutes, so I'm going to go ahead and stop the video here. And when we come back, we're going to finish the female, and we're going to finish our probabilities down here. And we're going to start talking about what the cost is per accident. And just to make things open up a little bit more so that we're in line, make a little adjustment here. All right, thank you very much, and I'll see you in the next video. Bye.